everybody, this is section 7.3, Logarithmic Functions and Their Graphs from our Hawks Learning College Algebra textbook for Math 101. Right, so a logarithmic function is defined as the inverse of an exponential function. So again, a log is the inverse of an exponential function. So if you recall, when we had an exponential function, we had y equals a of x. But notice, with the inverse, we now have x equals a of y, because again, they switched the x and the y. Or if you see it written in log form, this is where we bring in that word, that log. So x equal to the base a to the y power is the same as y equal to log the log of x with base a, or the log with base a of x. Right, so on the last slide we talked about how a logarithm is the inverse to an exponential equation. And if you recall, that exponential equation is, a to the x power is equal to y, or the log in exponential form is going to be a to the y power is equal to x, or if we write it in logarithmic form, it would be the log of x with base a equal to y. And so now what we're going to do is we're going to convert our exponential equations into logarithmic equations. So again, always look for the base of your power, which right there, it's the 2. So I'm going to have a log, and then I'm going to put the 2 as the base. It is going to be equal to x, which in our equation, if we look here, or not equal to, but our big number here is going to be the x, or the answer to the exponential, and then it's going to equal 3. So again, we're kind of mirroring, taking from this equation to put it into our log form. So for b, if we did the same thing, it would be the log of this big number would be the 625 would be on the outside. The little number is always the base of the exponent, so the 5. So it would be the log of 625 with base 5 is equal to 4. So whatever the power is, that's what it's equal to when you put it into log form. And then our last one, we have variables there, but we can still write it in log form. It's going to be the log of z with base 7, and it will be equal to x. Next, what we're going to do is we're going to take it out of log form and put it into exponential equations. So we're going to take it from this form right here and write it in this form right here. So if we have the log of 9 with base 3 is equal to 2, remember that little number is always the base of your power. The answer to the log is your power. So we have 3 to the second is equal to 9. And the big number in the log is the answer. Next, we are going to do, that is the log of 512 with base 8 is equal to 3. So it's going to be 8 to the third power is equal to 512. And then our last one down here, we're going to have 2 to the y power is equal to x. All right, next what we're going to do is we're going to look at logarithmic graphs. So just a caution, we have talked before about asymptotes briefly, and it's going to appear that a logarithmic function has a horizontal asymptote, but it really does not. It will ride right along that axis, but it will never touch it because they are the slowest, among the slowest growing functions in math. And if you take a look here, we have the log of x with base 2. And if we substitute in 1024, we get 10 for our answer. If we substitute in 2048, we get 11, and then 4096 gives us 12. So you can see how the growth is very minuscule. There's a lot of numbers between 1024 and 2048 to get between 10 and 11. So there's going to be a lot of little tiny jumps each time. All right, so next we're going to look at the graphs, and we're just going to briefly sketch them. Logarithmic graphs are hard to put into your graphing calculator unless we use log format, but typically when we graph it, we're going to put it in exponential form. So if I look at f of x equals the log of x with base 3. If I were to write that in exponent form, not log form, I would have 3. Instead of f of x, I'll put y. 3 to the y power equals x. And what we're going to do is we're going to sketch that, and so we can see just the basic shape of it. You want to just sketch it to look at the basic shape. So one easy value to always put in for y to 0. So if I do y, or 3 to the 0 power, I'm going to get 1. So that's one ordered pair. 3 to the first power, so if I put 1 in for y, is going to be equal to 3. And then let's do 3 to the negative first power. Typically, if you do 0, 1, and negative 1, you can get a good idea of the shape of the graph and where it goes. And I know that 3 to the negative first power is going to give me 1/3 because you are going to flip it. So now I have those 3 points that I can graph to see the basic shape. And again, it's not too hard to find those points. Find those points and then sketch out the graph, which we're going to take a look at on the next slide. All right, and here you can see our graph. We have the 3 points that we talked about sketched, 3, 1, 1, 0, and 1/3, negative 1. You can see the shape of the graph. And while there is no horizontal asymptote, there is a vertical asymptote, and that is the y-axis in this equation. All right, so here we have our other graph that they asked us, and it is g of x is equal to, the log of x to the base 1/2. So if we write that in exponential form, it would be 1/2 to the y power, because I'm going to replace g of x with y, equals x. And if I plot a few points to graph, again, plugging in 0 is nice because anything to the 0 power equals 1. Let's plug in 1. So 1/2 to the first power will give me 1/2. And then our last one that we're going to look at, we are going to do, let's do negative 1. I believe it's on there. But 1/2 to the negative first power, we flip it and we end up with 2. And you can see those points are plotted there. And we have that vertical asymptote of the y-axis. All right, now what we're going to do is we're going to look at some transformations of graphs with logs. And if you notice, here we have the transformation of the original graph, which was the log of x with base 3. And then now it is x plus 2 plus 1 on the outside. So we're going to look at, again, think about our transformations, how it is moved, either shifted up or down, left or right, and if it flips at all. So we're going to take a look at those graphs. And really, I don't expect you to be able to maybe necessarily graph these perfectly, but I want you to be able to sketch them based on the information that you know by looking at the graph and looking at the, what was the original log. All right, so here is our first equation, and it was the log. It had a base of 3, and then it was x plus 2 plus 1. So remember that plus 2 in there with the x means it's going to shift it left or right because they added 2. It's going to go to the left. And then this 1 on the outside, that'll shift it up or down. Because they added 1, it will shift it up 1. And then when you do shift this, you notice the y-axis is no longer your asymptote. Now it is shifted over to the left, and it's going to be, our asymptote is going to be that -2, x equals -2. All right, and so this one that we're doing is the g of x. I'm going to write it over here. G of x is equal to the log of the opposite of x minus 1 with a base 2. So our original equation, or the one that they transformed, is the log of 2x, or x with base 2. And so here we are subtracting 1 from the x. So that means that it's going to shift it to the, because it's a -1, it means it's going to shift it 1 unit to the right. And then also that x inside the parentheses is negative. So that means it's going to reflect it, and it's going to reflect it over the y-axis. So if you take a look here, we have our reflection, and which is right here, and it shifted 1 to the right. All right, and here is our last one. It was h of x is equal to the log of x minus 2 to the base of 1/2. So again, our original equation would have been 1/2 to the y power equals x, or the log of x with base 1/2. And so we can see here what they've done is they've subtracted 2, but it's on the outside of that variable. It's not inside with it. So that's going to mean a shift up or down. And because they subtracted 2, they're going to shift the equation down 2. All right, so now what we are going to do is we are going to look at evaluating the logarithmic expressions. We're finding out what they equal. And some of these are pretty easy, and others are fairly, you have to think a little bit about it. It's a little bit hard. So for A, we have, and I'm going to put it over here so I have much space. I'm going to write it in exponential form. So it would be 5 to the, and we'll say the y power equals 25. It doesn't really matter. It could be y or x. It's just to the power we're trying to find. So 5 to the y power equals 25. And I want you to ask yourself, 5 to what power gives you 25? And hopefully you're like, oh, we know that's 2. So that one equals 2. That one's pretty straightforward, pretty easy. Next for B, we have 1/2 to, and again, it doesn't matter what variable you use, we'll say the x power. It's going to equal 2. Now here, you should know, we go from a fraction to a whole number. So I want you to think we flipped. We have reciprocals there. So we are definitely going to have a negative power. And because we went from 1/2 to 2, it's going to be a -1. Now the next one for C, we have 4 to the what power equals 8. And this one's a little bit hard. We have to kind of think of like the powers of 4 to help us out. And I know that 4 squared is 16. But if I take the square root of 16, I get 4. So that's really not going to help me. But 4 to the 3rd power is 64. And what you want to look for is something where you can also get 8 out of it. And I know you can with 16, but not by taking a square root or anything. But if I have 4 to the 3rd power, I can take the square root of that, and it gives me 64. So if I do this, if I have 4 to the 3rd power and I take the square root of it, it gives me 8, because it's 64, and the square root of that is 8. So that means I have to turn it into fraction form. So this one, it's going to be 4 to the 3/2 power is equal to 8. And that one, again, was a little harder. You had to think those fractions in there. All right, now, the other one, the next one, D, you're going to say, well, this is kind of scary because it's got pi in there. Don't worry about that. We have pi to the x power equals the square root of pi. Anytime you go to the square root of something, think, what fraction do you use to help get that square root symbol? So really, I'm hoping you're saying, oh, I know that anything with the square root is the same as the 1/2 power. So if I have pi to the 1/2 power, it will give me the square root of pi. All right, for E, we have 17 to the what power or x power equals 1. And this one, when you look at it, at first you're like, oh, this is really hard. But remember, any number to the what power always gives you 1. Hopefully you're like, oh, any power or any number to the 0 power always gives me 1. All right, next we have 16 to the x power equals 4. And I want you to think, we went from a bigger number to a smaller number. So what would we do if we go from a bigger number to a smaller number? 16, if you recall, if we take the square root of it, we get 4. So the same thing for square root, the power would be equivalent to 1/2. All right, and our next one is, so it's 1/9 to the x power equals 3. All right, so for this one, I know that I'm going from a fraction to a whole number, so they're reciprocals. So I know I'm going to have a negative exponent there. And not only that, but my 9 is turning into a 3. So remember, we are also going to have a fraction for our exponent. So for this one, the square root of 9 equals 1/3, or the negative 1/2 power would give me 3. So that one's going to be equal to the negative 1/2 power. And then the last one we have 10 to the x power is equal to 1/100. That is going to mean that we are going to we need to have, again, a negative power. So we're going to have 10, and to get to 100, it would be 2. To get to 1/100th, it's going to equal a negative 2. And again, sometimes with these, you got to play around with them, try them out on your calculator, see what you think, and then find your answer. It's just really working with those powers to find it. All right, and the last thing that I'm just going to mention are the difference between common and natural logs. When you have a base of 10, this is called a common log. And it's written just log of x. They won't put the base in. It's kind of like the square root. They don't put the 2 in there. But they'll put just log of x. And then a natural log is with the base of e, that irrational number we talked about. And usually they write it as the ln or ln of x. So that's your natural log. If you see the ln, or they call it ln, but ln of x.